Hi, everybody. So I'm Steph. So I'm a postdoc and also project manager on the STEAM project, which we heard about earlier with the first nano session. But for those of you who missed it, I'll just give a brief overview. So with STEAM, we're looking at trying to store renewable energy as heat in flooded and abandoned mine shafts so that when the wind isn't blowing, the sun isn't shining, we can actually kind of get some heat into homes and businesses and not all freeze when it's kind of one of those cold weather weeks where there's no wind, everything's frozen, and it's just not very comfortable. So we're interested in mine shafts because in principle, they are much more geometrically simple than the kind of big kind of underground mine galleries. We're just looking at a tube, potentially a few hundred meters deep, potentially millions of liters of water, surrounded by naturally insulating rocks, so they're potentially really good thermal stores. So as part of STEAM, we're looking at doing a national assay of the UK's mineshaft resource, and we're also looking at trying to work up 3 to 5 detailed case studies. And as Zoe mentioned, we're looking at actually doing an experiment and sticking some heat into a mineshaft. Now, some of those case studies, we started looking at Barony Colliery in Ayrshire. Barony number 3 shaft is, it's got a nice big A-frame over the top. It's a really nice little memorial park to the colliery. And then we later decided we're actually going to move the experiment to Monkton Hall, kind of just down the road from here. So those are the 2 collieries that I've done the most characterization work on, and a lot of this talk is based on that kind of work. But I thought I'd give you a bit of a guided tour of some of the sources I've come across and used and found most useful, whilst kind of trying to pull together all the desk studies and the background information for kind of de-risking this work. So what do we need to know about mine shafts if we're going to use them as thermal stores? So there's 3 main reasons that we actually want to learn about mine shafts. The first is feasibility and capacity. It's kind of, can we actually stick enough heat into a mine shaft for it to be useful? Can we get at it, or has it got a supermarket built on top of it? We need to know, is it safe and stable? And we need to know, is it going to be an efficient way of storing heat? So what kind of things do we need to know about the mine shafts that will tell us these kind of questions? So first off, accessibility. Can we get at it? Basic geometry, so kind of depth, diameter, shape. Has it been filled, or is it still empty? Is it full of water that we can heat up, or is it all dry? Then, as Indrani was explaining, we need to know about the water chemistry to kind of know, is it actually going to be safe? Are we going to have any environmental pollution problems? Or is it just going to actually cause problems with everything scaling up and it's going to have an operational problem rather than an environmental risk? The hydrogeology of the mine shaft itself, is it kind of connected to other shafts? Where are the connections to the deeper mine? Do you have flow throughout that? Is the shaft itself kind of leaking somewhere and kind of interacting with the local groundwater? And that relates to things like the shaft lining, the architecture. The age is not a kind of a clear factor, but for example, older mine shafts tend to be more brick-lined, younger mine shafts tend to be more concrete-lined, so there's different aspects there. The surrounding lithology and stratigraphy can have an impact on the kind of strength and stability of the shaft, as Huachan was telling us about before, and potentially also they might have different thermal properties in the different rock types there. So that's all important. And then from a safety perspective, we need to know, are there any gases coming up through the mine shaft? We're going to be looking at putting heat into here, so is there a spontaneous combustion risk? Are there any shallow workings that are directly or indirectly connected to the mine shaft? And finally, from a kind of social acceptability perspective, it's worth thinking, had there totally been any deaths at that colliery? There's some places, so at Barony, there's the bodies of miners are still entombed in the colliery itself from when 2 of the other shafts collapsed. So it's important to be aware of the social issues around this. So I'm going to start with accessibility, just because that's nice and easy. And while this talk labelled it about historical records, Google Earth isn't a historical record as such. It's kind of more current, but it's a big helper with this. So this is Barony number 3 shaft. As I said before, you've got big A-frame on top. You can clearly see there is a mine shaft here. You can see it from the sky, you can see it from the ground. A little less clear, here we've got Rothes number 1 shaft in Fife. And you can see that little red dot there, that's where the mine shaft is. So you can see on the aerial photos and satellite images that there's something there. It's big and round. Kind of looks like it might be a mine shaft. And then if you go on Google Street View, you can see you've got this big kind of concrete circular cap. So we've got a pretty good idea that, yes, that's where the mine shaft is, and it's going to be relatively accessible. We don't know what it's like underneath the cap yet, but that's a good start. Compare that with Sunderland and Monk Wearmouth Colliery, where the Stadium of Light has been built on top of it. So we've got 2 mine shafts in this satellite photo here, but there is no way that we would actually be able to kind of get access to those to stick heat in, not unless you want to demolish a big stadium. And it'd be interesting to know whether whoever parks on parking spot number 8 realises that they're parking themselves right on top of an abandoned mine shaft. So one of the first ports of call, if you're looking at UK-based mine shafts, is, of course, the Coal Authority interactive map. I'll not spend too long on this because I'm sure most of you are aware of it. But what I wanted to flag here is that there's been some new data sets added in the not too distant past, which you might not be aware of. So originally, we had the planning interface. More recently, we've got the coal mining data, mine water heat, and environment agency data tabs have all been added. You find those at the little blue tab in the top right-hand corner. And I've ticked here, these are the data points that we've kind of applied to get access to and used in our characterization. So these are the ones that are probably going to be the most useful for characterizing mine shafts. I've also just kind of given an example of the map here. So this is Monkton Hall number 2 shaft, just down the road in Edinburgh. And this gives you an example of kind of information that you can get in the national database of the mine entrances. One thing to be aware of, though, is in the mine water heat section, a lot of the data in there, you can't actually get access to data immediately. You need to it tells you what data is available, and then you have to apply for the data. So if you are kind of planning a study, build that timeline into actually getting hold of the data and investigating it. So in terms of the mine entries database itself, there's over 175,000 data points. That's a lot. And kudos to the Coal Authority for actually pulling together all that information. But as you'd expect with such a big database, it's not complete. We've only got, for example, shaft names for only 44% of those entries. The things that we're interested in from a thermal storage point of view are things like, has the shaft been treated? So that means, has it been filled in? Has it been capped? And the database tells you true or false if it's been treated. If you want to get the information about that treatment, you apparently need to apply for a mining report from the geotechnical team. So that's one kind of level of uncertainty there. You're never entirely sure what information is available about that until you apply for it. And there's only records on the shaft treatment for 25% of the shafts. So that's quite a small subset, but 25% of 175,000 is still quite a lot. The other thing I want to draw attention to here is that there's 2 fields for shaft diameter. One is the assumed diameter and the other is the actual diameter. So there's assumed diameter values available for over 90% of the shafts, which is great, and actual diameter available for just 10% of them. And here at Monkton Hall, we've got values for both of them. And as you can see, if we've got the 2 shaft diameters there, the assumed diameter and the actual diameter are actually quite different. So this is just to make you aware, I think with any kind of historic mining data, you need to be aware of potential inconsistencies and try and find other ways of corroborating the data that you've got. Try and find multiple sources of information to back up the information that you're basing your studies on. So the mine entries database, it kind of ticks a lot of those boxes to some extent, maybe not kind of definitely 100% all the information that we need, but it's starting to fill in our jigsaw and give us the information that we need. So how do we fill in some of those other gaps? BGS Onshore Borehole Database is a great resource. You can actually download the original log for a lot of shafts. So while this is a borehole database, it does include actual mine shafts and the stratigraphic logs. Some of the problems with this is an example. I think this one's Monkton Hall again. I don't know about you, but I can't read this handwriting. So trying to actually translate some of the borehole records can be a little bit tricky at times. But this will give you a nice detailed stratigraphy that you can put into models. So we've added in lithology and stratigraphy there, and the borehole database does also include age, which isn't part of the mine entries database. Then we can look at mine abandonment plans. So again, the Coal Authority's got a massive database of abandonment plans. The kind of really big bits of kind of paper or drafting film, and thankfully they've all been digitized. If you are searching the Coal Authority database, make sure that you do an area search rather than just searching by keyword or name, because sometimes there might be a typo, there might be multiple ways of spelling a place name, and that all gets a bit confusing. Whereas if you just kind of do a geographical area search, you're more likely to get the information that you need. So what information do you get on abandonment plans apart from seam workings? You actually get quite a lot of information about the shaft geometry and the basic stratigraphy. So this is an example from one of the Barony abandonment plans, and it tells you the different shafts that are available, what the different surface landings are in that. So that's telling you something about the depths of the roadways coming off the shaft, and it gives you a bit of the stratigraphy. You can also sometimes get the shape of the shaft. So here we've got square shafts as opposed to round shafts. So we're filling in the gaps a bit more there. Coal Authority has a publication on spontaneous combustion. So the link's there if you need to look that up, with the caveat that just because a seam doesn't have a history of spontaneous combustion doesn't mean that it won't happen. And then finally, mining museums are a brilliant source of information. We've got some really interesting information from kind of what we think are quite obscure places. So we've got a leaflet here, which was the case for reopening Monkton Hall after it was closed in the late 1980s. And this tells us that it's a low sulfur coal, so that actually tells us something about the gas risk analysis, because we don't need to worry about hydrogen sulfide in this case, probably. We also get some nice copies of some of the original stratigraphic logs from when the shaft was being sunk. So these actually have more detail on them than the BGS ball database. And then we've managed to find some reports that tell us about water pressure within the shaft, kind of water flow, water problems, a report about concrete stability in the shaft when it was reopened. And we even found this lovely report that gives concrete shaft thickness along the length, which we were really excited about when we found it, until we realised, if you look at this top, it claims at the top kind of 50 metres, there's no concrete, but we've looked down it and it's definitely concreted at the top. And we're also pretty sure that this scale of millimetres should be centimetres. So again, it's important to kind of take everything with a pinch of salt, check that the information you're getting from historical records makes sense, and corroborate it wherever you can. And for deaths, we've got the Scottish Mining website. Durham Mining Museum has quite a lot of information about disasters, accidents, which is a good resource. So yeah, with all of those different sources, we can actually fill in a lot of the knowledge gaps that we're after, and hopefully pull together a kind of a good picture of the shaft to be able to start building kind of contributing to all the models that we've been doing with steam and de-risking sites and using hot water storage tanks. Thank you.